I am looking at some information on pixel buffer objects. I haven't really read it all. I've just kind of skimmed through it. This diagram right here looks interesting. Just talking about how we can asynchronously call GL text image 2D if we put things into a pixel buffer object, because then the transfer from the RAM to the VRAM is a direct memory access that is controlled by OpenGL rather than having to synchronize between the CPU and the GPU. This all seems like a great performance boosting kind of thing, except I did a quick Google search and it doesn't look like you can get this extension in WebGL2. So I was also reading, and supposedly GL text image 2D can be really fast as long as you use the internal format that matches the internal format of on your GPU. So I guess GPUs like something like GBA something. I don't know. Instead of RGBA, it's like inverted, and I believe it starts with a G. So I think it's it's GBR, right? So it's RGB inverted, but it still has the alpha at the end. And I guess that's the pattern that most GPUs prefer. And if you use the format that the GPU likes, there doesn't have to be any conversion when you do your pixel pack and unpack operations. And that increases the speed of the transfer. Technically not the speed of the transfer, but it's like, right, once the train gets from A to B, the passengers still have to get off, right? And if you've ever been on, like, I haven't really been on many trains, but let's say a plane, right? The plane's pretty fast, and I swear to God, like half your trip is just getting on and off of that plane, right? And you could think of that as a pixel pack unpack operation. So flying from Michigan to Seattle, that's like your pixel transfer. But then you got to pack and unpack, and that's like boarding the plane and then getting off the plane. But that intermediary part is actually very fast. And a lot of the speed is actually in that pack unpack. A lot of where that speed is lost is just the pack unpack operations, not actually transferring the data across from CPU controlled memory to GPU controlled memory. So I might want to like somehow make a benchmark to I might want to make a benchmark or something to figure out what the best internal format is, but I don't know how that would be done. I think I have some ideas, but I know exactly how I would do that. So when I am programming, I might want to make sure that I leave a little bit of flexibility for being able to flip the format around. So right, if we look into where we're like setting up, right, like these equations here are assuming RGBA, but we might want B, G, R, and A. So that's a consideration I should probably think about. Like I might want to encapsulate set pixel operations on the CPU so that at any time I can flip around that format and have everything work smoothly rather than having like all these refactor points. But I'm not quite certain on that. So I'm gonna try to look up what the how to detect the preferred GPU format using WebGL. Like, is there a way? One way you could kind of actually do it is you could try to set up WebGL use one type of pixel format, push a whole bunch of data to the GPU, and time that. And then you could use another pixel format, push a whole bunch of data to the GPU, time that. And after you've done those tests, you could decide on the pixel format that the game will use for the rest of the time, right? So like on boot up, the game would do a little bit of like optimization tests and then determine its configuration based on whatever it discovered. But that means that that could make some hard to maintain code though, right? Because now you don't really control what, like now you're working with possibly 2 different data sets, 3 different data sets, depending on how many different formats you want to try to test with. And you don't know, I don't know, that, I just feel like that's going to, right now you have like these different configuration states that the game could be running in, and if something goes wrong in one configuration state, like maybe something goes wrong in RGBA, but maybe because of some slight differences in your code, it only crashes in RGBA mode, but it doesn't crash in BGRA mode because there's probably like a slight mistake in your code somewhere, and now people are thinking it's some type of driver problem instead of your actual code. But it's like, that's weird, it only crashes when the pixel format is this with other, you know? So that's potentially causing a lot of parallel code that needs to be parallel maintained. It's a good thought for like an optimization, but maybe we're getting ahead of ourselves trying to optimize to that extreme of an extent. But either way, I am going to go online and check to see how you would detect the internal format, and see what I find, but maybe I'll just stick to whatever format seems to be the fastest for most GPUs. Alright, later.